This is problem number 23 in section 4.2, and it's similar to number 23 in the textbook also. And as you read through this problem, let's just go to the last sentence, or pretty close to it. It says, how many of each of these, how many car seats should we produce, how many strollers should we produce, and how many travel yards should we produce in order to maximize our profit? So let's see, what we're going to do here is let X be the number of car seats to produce, Y be the number of strollers to produce, Z be the number of travel yards to produce. So let's summarize this information in a table. We'll have car seats, strollers, travel yards. These are our categories, right? We have the categories that get the categories from right up here. This is what I'm looking for. Car seats, strollers, travel yards, and each of these categories has certain characteristics that go along with them. Each of them takes some time for creation, some labor hours for assembly, and some labor hours for finishing and packaging. Now we're going to have some available hours over here, so let's get our table and fill it in. So from the very top, I can see that car seats require 5 hours of labor, each car seat 5 hours of labor for parts and creation, 4 hours for assembly, and 2 hours of finishing. The strollers require 3 hours of labor for creation, 3 hours of labor for assembly, and 1 hour for finishing. And each travel yard requires 2 hours for creation of labor and 3 hours for assembly and 1 hour of finishing and packaging. Now, reading on in the problem, here's what we have. There's 450 hours available for creation. So this has got to be less than or equal to 450 because we don't have to use all of them, but we have at most 450 hours available for us. Less than or equal to 380 hours for assembly, and less than or equal to 140 hours for finishing. And then we're going to have our profit. I'm going to put down here in the very last row. So our profit is this. Car seats produce $30 profit, strollers $10 profit, and travel yards $18 of profit. So our objective is to do this. We want to maximize, see it here, 30x plus 10y plus 18z subject to these constraints. So from the very first line here, we're going to have 5x plus 3y plus 2z is less than or equal to 450. Make that look like a 5. And then we'll have 4x plus 3y plus 3z. That's going to be less than the 380, less than or equal to. And then we'll have 2x plus y plus z. That's going to be less than or equal to the 140. And of course, x greater than or equal to 0, y greater than or equal to 0, and z greater than or equal to 0. So this is our linear program, and we can just type this straight into Zwig Media and get our solution. This is problem number 23 in section 4.2, and as we read through the problem, we're mixing up some soils. So near the end, I'll just go right to the end. It says, how many bags of mix A, mix B, and mix C should we make in order to maximize our profit? So let this summarize all the information in a table. We've got mix A, mix B, mix C, and then something available here. And so our categories, as we know, we put our categories down these columns here, and the categories are exactly what we're looking for here. And each category, each one of these categories has certain characteristics. I'm going to write those characteristics down the side here. And as I read through this, I can see that, say, each one of these categories has some made up of, what do we have here? We have peat, and of course the same letter. Then we've got perlite, and then we've got organic material. How about organic material? And then we have profit. So what are weekly profits down here? Now let's run through this. So let's just read through these sentences here. Let's see, what we've got is Mix A has 12 pounds of peat, 5 pounds of perlite, and 3 pounds of organic material, and earns a profit of $3 for a 20-pound bag. Okay, and these of course are, as I read, are all in 20-pound bags. Now, for B contains 10 pounds of peat, 6 pounds of perlite, and 4 pounds of organic material, and brings a $5 profit for every 20-pound bag. And Mix C has 8 pounds of peat, 8 pounds of perlite, and 4 pounds of organic material, and they bring a profit of $6 for a 20-pound bag. And just a note that if you add these numbers up, you get 20, right? Because we're supposed to have 20-pound bags, just as a check. Now, reading on, here's what we have available. There's 1,200 pounds of peat, so the available amount of peat here is going to be, that has to be less than or equal to 1,200. Let's see, what do we have for perlite? That's going to be less than or equal to 800. And organic material is less than or equal to 600. So just taking this information here and putting it into our linear program, here's what we're trying to do. We're trying to maximize profit. P equals 3x plus 5y plus 6z, subject to these constraints. So you can see the constraints are here. 12x plus 10y plus 8z less than or equal to 1,200, and so on. So here is our linear program, and we can solve this if we just put this into our ZWIG media. So here's what I got anyway when I put this into ZWIG media. I got these values. You can see that X is inactive, so X is 0, so we're going to mix no bags of Mix A. Y, we have a 1, and the rest are 0, so this is active. So Y is going to be 100, so we're going to build 100 bags of Mix B. Z is also active. There's a 1 and all 0, so Z is equal to 25. So we will put together 25 bags of Mix C. And notice here also that what we have is that U, or S1, is 0. S2 is 0, but S3, well, if we kind of read it here, it's a little bit tricky. S3, there's a 1 there, and so S3 is equal to 100. So let's write our conclusion here. So our profit is going to be maximum right here when P is equal to P is 650, so that's our profit. Our profit is maximum at 650 when, so our profit is going to be maximum at $650 when we put together no bags of Mix A, 100 bags of Mix B, and 25 bags of Mix C. Now, if we take a look at our slack variables, S1, this is the number of pounds of peat that we have, and originally we had 1,200 pounds now available. So this is 0, so we're using all of our peat. We have 0 unused pounds of peat left. S2, or V, this is also 0, and S2 was the number of pounds we had available of perlite, and that's 0. So we have no unused pounds of perlite. We're using all of that. And to begin with, we had 600 pounds of organic material, and you can see that S3, if you read it carefully, S3 is 100. We had 600 available. We now have 100 unused. So we still have 100 unused pounds of organic material. Maybe we can do something else with that.